Chapter 2, Kinetic Factors, Class Life Sciences. Part 4, Catalyst. At the end of this session, students should be able to define catalyst, identify the characteristics of a catalyst. 4.1 Definition. What is a catalyst? This experiment will show us the definition of a catalyst. Tartrate salt reacts with hydrogen peroxide H2O2 to produce carbon dioxide gas, but this reaction is very slow even with moderate heating. Add cobalt chloride solution. Cobalt ions are pink. We observe a change in color and the formation of bubbles. Release of CO2 is accelerated. That means the reaction is accelerated. The reaction becomes faster in presence of CO2 plus ions. Then CO2 plus ions plays the role of catalyst for this reaction. The catalyst is modified during this reaction. The pink ion CO2 plus are transformed into green ion CO3 plus. Then the pink color of CO2 plus ions reappear. That means CO3 plus are transformed into CO2 plus again. Then the catalyst is regenerated at the end of the reaction. Then CO2 plus ions accelerate the reaction and modified into CO3 plus, then regenerated into CO2 plus again. Then the definition of a catalyst. A catalyst is a substance that accelerates a chemical reaction and remains unaltered at the end of the reaction, remains the same. The catalyst then is a kinetic factor. During the reaction, the catalyst is modified, then it is regenerated at the end, and it can be used again to catalyze another reaction if this catalyst is solid. Characteristics of a catalyst. First characteristic is activity. A catalyst is characterized by its activity. What is the activity of a catalyst? It is the capacity of a minimum quantity of this catalyst to increase the rate of the reaction. The lesser the quantity of the catalyst which is capable to cause a noticeable increase in the rate of the reaction, the more active is the catalyst. For example, if we have two catalysts, catalyst 1, we need 1 gram to accelerate the reaction. While for the same reaction, if we use another catalyst, catalyst 2, for example, if we need 5 grams of this catalyst, to accelerate the reaction, we deduce that catalyst 1 is more active than catalyst 2 because we need less mass or amount to accelerate the reaction. This is the activity of a catalyst. In solid catalyst, the more the catalyst is in contact with reactants, the more efficient is the catalyst. For example, same mass of powdered platinum is more active than platinum wire or platinum plate. Then when the solid catalyst is in powdered state, it is more active than it is one piece. B. Selectivity. This is very important. Sometimes for the same reactant, the catalyst determines the nature of the reaction. For example, ethanol CH3CH2OH. In presence of Cu as catalyst and heating, by heating, we obtain aldehyde ethanol and hydrogen gas. This reaction is called catalytic dehydrogenation. We will see it in chapter aldehyde and ketones in organic. While if we change the catalyst, same reactant, ethanol, but we put aluminum oxide instead of copper, by heating, we obtain ethene plus water, that means catalytic dehydration. Then, when we change the nature of the catalyst for the same reactant, we obtain different product, that means the nature of the reaction is changed. This property is called selectivity of the catalyst, because the catalyst select the nature of the reaction. The catalyst determined the nature of the reaction. This is the selectivity of catalyst. Third property or characteristic, a catalyst cannot make possible an impossible reaction. For example, if we put SO4 sulfate ion with iodine, we have no reaction. This is an impossible reaction. If we put a catalyst, we have no reaction between SO4 and I2, even if we put a catalyst. Then the catalyst cannot make impossible reaction possible. Only the possible reactions, the effect of catalyst is only on possible reaction. It accelerates a possible reaction. If we have impossible reaction, the catalyst has no effect. D, a catalyst could not be a reactant for the reaction. The catalyst is shown in a chemical equation by being written above the yield arrow. For example, the decomposition or reaction of hydrogen peroxide catalyzed by platinum PT, H2O2 give H2O plus half O2. The catalyst is written above the arrow, PT. This is the correct writing of the equation of the reaction. If we write H2O2 plus PT give H2O plus half O2, this is wrong written of the equation, because in this case we consider PT as react, because reactants are written before the arrow. If we put the catalyst before the arrow, then we consider it as reactant, and this is wrong case. The catalyst should be put above the arrow, not before the arrow. Then a catalyst is not a reactant. Application 1. The oxidation of iodide ion I- with peroxide sulfate S2O8 2- ion is given according to the following equation. 2I- plus S2O8 2- give I2 plus 2SO4 2-. Two experiments 1 and 2 are performed starting with the same initial concentration of reactants, the same temperature in each experiment, but adding few drops of iron 3 sulfate solution Fe2SO4 3 times in one of them. The results are represented in the following table. Experiment 1. In absence of Fe3 plus ions, initial rate 3.65 10⁻⁴ mole per liter per minute. Experiment 2, in presence of Fe3 plus ions, initial rate increases to 9.75 10⁻⁴ mole per liter per minute. Deduce the role of Fe3 plus ions. Fe3 plus ions is not a reactant. The addition of Fe3 plus increases the rate of the reaction, then Fe3 plus is a catalyst for this reaction. Then, starting from the same initial concentration of reactant, same temperature, but the presence of Fe3 plus ions in experiment 2 and absence of Fe3 plus ions in experiment 1. This is the difference between the two experiments. Result: initial rate in experiment 1 bigger than in experiment 2 bigger than initial rate in experiment 1. Then the presence of FeC plus ion accelerated the reaction, and since it is not a reactant, then FeC plus plays the role of catalyst for this reaction. Application 2. The diagram below represents two chemical reactions. CO plus H2 in presence of Cu gives CH3OH, while in presence of Ni nickel gives CH4 plus H2O. Based on the diagram, deduce a characteristic of catalysts. Starting from same reactants, when we changed the catalyst, the nature of the reaction, that means the products are different, then the characteristic of catalyst is the selectivity. Solution: starting from the same reactants, when we changed the catalyst, the nature of the reaction changed, different products, then this result shows the selectivity of catalyst. This is the end of part 4 of chapter 2, kinetic factors, the catalyst, and the end of chapter 2, kinetic factors.